Welcome back to Chem Coding. Today we're talking about one of the most useful data structures in Python, especially for chemistry. Dictionaries, or dicts for short. If you've ever tried to store data like element to atomic weight or symbol to atomic number using lists and felt your brain melting, this video is going to make your life much easier. Why dictionaries instead of lists or tuples? In chemistry, data often comes in pairs: element and atomic weight, molecule and molar mass, ion and charge. You could store glucose in a tuple like this. But now you have to remember index 0 and 1 are C, 2 and 3 are H, 4 and 5 are O. One off by one error, and you've discovered a brand new element. With a dictionary, this reads exactly like the formula itself. C maps to 6, H to 12, O to 6. Much more human-friendly. There's also a performance win. Looking up data in a list is like flipping through a textbook page by page. Looking it up in a dictionary is like clicking a hyperlink from the table of contents. I tested a list and a dictionary, each with 1 million items, and timed how long it took to find the last item. List lookup about 0.006513 seconds. Dict lookup about 0.000001 seconds. That's roughly 8,684 times faster. For small data, you won't notice much difference, but for large chem or bioinformatics databases, it can be a night and day difference. In this first video of the two-part series, we'll focus on the basics of dictionaries: syntax, creation, modification, access, iteration, and simple comprehensions with chemistry-themed examples. Dictionary syntax and valid keys values. A dictionary is a collection of key-to-value pairs inside curly braces. Here, H, HE, LI are keys. 1.008, 4.002, and 6.94 are values. Rules you need to remember: keys must be immutable and unique. Valid keys: strings, integers, floats, tuples. Invalid keys: lists, other dictionaries. Values can be any type and don't have to be unique. For example, a dictionary of group 18 elements. Here. Same value, different keys. Totally fine. Some more examples: atomic data 1, valid. Atomic data 2, invalid. Lists as keys are used. Atomic data 3, valid. Tuples as keys. Atomic data 4, valid. Lists as values. If you try atomic data 2, Python says, type error, unhashable type, list. You don't need to fully understand hashing right now. Just remember, keys must be immutable and unique. What if you accidentally repeat a key? Python will keep only the last value. So if you have duplicate keys in the literal, the earlier ones get silently overwritten. Your editor may warn you, but Python won't stop you. Alternative ways to create dictionaries. Just like lists and tuples, dictionaries can be created with the Dict constructor. Empty dictionary. Empty dict equals Dict. If you print empty dict, it gives you just empty curly braces. Print type of empty dict gives you class Dict. Using keyword arguments. Here, H and HE are keyword arguments that become string keys H and HE. Dict underscore PI equals 3.14 works. Dict 1 equals 3.14 fails because 1 is not a valid variable name. If you want something like 1 is a key for H, it's a bit verbose, but it works. Setdefault. Setdefault is useful when you want to insert a key-value pair only if the key doesn't exist yet. Suppose you have a dict, elements. Then add new element equals elements.setDefault BE 9.012. If you print elements, you see BE 9.012 is added. If you omit the default, now if you print elements, you see BE none is added. If BE exists already, setDefault just returns the existing value and doesn't overwrite it. So it's like saying, add this if it's not there, otherwise, don't touch it. Nested dictionaries. Now, let's store richer information about elements. Example, period 1 elements with name and atomic number. You can think of it like this. So now, period 1, H, atomic number, gives you 1. This is basically a tiny, custom-made periodic table. Accessing items, subscripting, and get method. Dicts use keys instead of indices. For the dict elements, print elements li gives you 6.94. You can also use get method. Print elements.get he gives you 4.002. Now, what if the key doesn't exist? If direct indexing is used, the program crashes at the key error, and "Did I survive?" never prints. Using get, print elements.get be gives you none, and this line, print "Did I survive?" runs. You can also provide a custom message in get method. Print elements.get be key is not in the dictionary. We'll print key is not in the dictionary. So get is safer for missing keys, especially in longer programs. Accessing nested and complex structures. Let's revisit the more involved example. Print group 1 elements 1 gives you the entire value, list, curly bracket, hydrogen, curly bracket, comma, curly bracket, lithium, curly bracket, square bracket. Here, 1 is a key, and the value is a list. Print group 1 elements 1 square bracket 0. Now we access the first item in that value list. Dive deeper. Print group 1 elements 1 square bracket 1 square bracket lithium square bracket. Curly bracket symbol Li, comma Z 3, comma mass 6.94. A value for the key lithium. And finally, print group 1 elements 1 square bracket 1 square bracket lithium square bracket Z. Give the value 3 for the key Z. It's like zooming in, dict to list to dict to dict. Does a key exist? To check if a key exists or not, use in, not in. For the dict group 1 elements, if you do if hydrogen in group 1 elements, it will print no, it is not in group 1 elements. Why? Because hydrogen is not a top-level key. The only top-level key is 1. The correct way to check if hydrogen exists, do if hydrogen in group 1 elements 1 square bracket 0. Then it will print yes, it is found. So always make sure you're checking membership at the right level. Modifying dictionaries. Dictionaries are mutable. You can add, update, and delete items. We start with Elements Dictionary, adding items by direct assignment. Elements, subscript BE equals 9.012. When you print elements BE is 9.012 is added to the dict. Adding with update method. Elements.update, parentheses, curly braces, BE, 9.012, close curly braces, close parentheses. If you print elements, you see BE, 9.012 added. Modifying an existing value. Direct substitution. Elements subscript HE equals 4.001 changes the dict to curly brace H, 1.008, comma, HE, 4.001, comma, LI, 6.94, close curly braces. Or use update again. Elements.update, parentheses, curly braces, HE, 4.001, close curly braces, close parentheses, to get the same result. Removing items. Use del. Del elements subscript H. Removes H key and value 1.008 from the dict. Using pop key. Elements.pop, parentheses, HE, close parentheses, removes corresponding item. Using pop item, removes the last item. Elements.popItem. Yes, dictionaries are mutable, just like your lab notebook, except you don't need whiteout. Iterating through dictionaries. Let's look again at elements dict. Iterating over keys, or more explicitly using keys method, will print keys H, HE, LI. Iterating over values. You use values method. For v in elements.values, this will print values 1.008, 4.002, 6.94. Iterating over key-value pairs. Use items method along with k and v tuple unpacking. For k and v in elements.items, this prints key and pair h 1.008, he 4.002, li 6.94. Or if you want the tuple itself, do like this. For t in elements.items, here t is the tuple, and when printed, we have tuples h 1.008, he 4.002, li 6.94. Iteration is crucial for tasks like summing up molar masses, something we'll do in the next video. Extracting lists from dictionaries. Again, using the elements dict. To get list of keys, keys list equals list of elements, same as list of elements.keys. We get h, he, li. To get list of values, values list equals list of elements.values. We get 1.008, 4.002, 6.94. Likewise, to get list of key value tuples, items list equals list of elements.items. This is handy when you want to pass data into other tools like NumPy or Pandas. Getting keys from values with comprehension. Sometimes you want reverse lookup, which elements have this mass. To find out keys with value exactly 4.002, symbols equals k for kv in elements.items if v equals 4.002, which gives he as expected. If keys with values less than or equal to 4.002 is wanted, symbols equals k for kv in elements.items if v is less than or equal to 4.002. It gives he. This is like filtering the periodic table by mass. Quick intro to zip function and dictionary comprehension. We'll use these more in part 2, but let's at least see the basics. What does zip function do? It produces a zip object, an iterator, a sequence of tuples that generates pairs on demand. Zip does not immediately create a list, tuple, or dict. It will generate one only when you iterate over it or used with list, tuple, or dict functions. Since Python 3.7 Plus dictionaries are ordered, zip is now much safer to use because the sequence of keys and values remains consistent. When using zip with dictionaries, always ensure 1. Same length, 2. Same order. Suppose we have two lists, it can be tuples as well, and create a list, tuple, or dict with elements paired position by position. Zip function just does that. Symlist equals HELI, zlist equals 1, 2, 3. You zip them and generate a list, tuple, and dict. MyList equals list, zip, symlist, zlist. MyTup equals tuple of zip of symbol list, zlist. MyDict equals dict, zip, symlist, zlist. Zip pairs items position by position. When used with dict function, it turns parallel lists into a dictionary. Dictionary comprehension. Suppose we have a list of tuples. Element list equals parentheses h, 1, parentheses, he, 2, parentheses, li, 3 parentheses. Corresponding dict can be created with dict comprehension like this. Dict equals curly braces, e bracket 0 bracket, colon, e bracket 1 bracket for e in element list. This creates h colon 1, he colon 2, li colon 3. Or if keys and values are in separate lists, symlist equals h, he, li, zlist equals 1, 2, 3. Zip function can be used in dict comprehension. Dict equals k colon v for k comma v in zip, symlist, zlist. This creates h colon 1, he colon 2, li colon 3. We'll use dictionary comprehension more heavily in part 2 for real chemistry applications. So in this first video, we covered why dictionaries are better than lists or tuples for many chemistry tasks, how to create, access, and modify dictionaries, nested dictionaries for richer chemical data, iteration, membership checks, and simple comprehensions. In the next video, we'll apply all of this to actual chemistry problems, computing equilibrium constants from dictionary-encoded expressions, calculating molar masses from formulas, and predicting ionic compound formulas using charged dictionaries and a bit of number theory. If that sounds fun, yes, fun and equilibrium constants in the same sentence, stick around for part 2. In part 2, we'll turn these dictionary tricks into real chemistry tools. See you there.